Hello everyone. So today I will be taking part 2 Docker hands-on lab. So in the previous week I have taken part 1 where in I have taken some Docker basics and introduction to Docker. So today what we will be learning is quick recap. I will be giving you quick recap whatever I have told in the last session. So you can go always subscribe to Sayam Pathak's channel and go there and see what and all is happening when we are coming live. And you can again go through my video. If you have not attended part 1, no worries. You can go and check out my part 1. So then I will be taking what is Docker file, image and Docker containers. And then I will be explaining you about container lifecycle, then attach and detach modes, and of course then we will be doing hands-on lab using Katacoda. So in my part 1 I have used play with Docker. So if you're comfortable with play with Docker, you can go ahead and do so. And another thing, if you want to install Docker, you can just do that as well using yum install docker -y. If you have Ubuntu, then you can just go ahead and do sudo apt install docker. So you can do these are the things you can perform. For now, today I'll be using Katacoda. Okay, so before moving to Dockerfile image, I will give you a quick recap. So in part 1, we learned that Docker is a powerful tool that is used for creating and deploying applications. So it is written in Go and released in 2013. So Docker is used to run packages called containers, and containers are isolated from each other and from the OS. These are more lightweight than the VMs. In the last part, in the part 1, I have described the difference between the VM and Docker as well. And so these are more lightweight than the VM, and they do not use the host machine to run the OS. So this is again a quick recap which I'm giving. And application runs using Docker will start up the same every time on the every system. If you're using a development environment, production environment, or any other source OS, base OS, so it will run the same way it runs for in every environment. So now this was a little bit of recap, and in the last part I have explained you about Docker images and Docker container ls, Docker ps, little about these commands. So you can always go back and check out my video. So now moving on, I will be explaining here what is a Docker file, image and containers. As last time when I was doing live stream, many people asked me about it. So we will first go through this quickly. So what is a Docker image basically? So Docker file. So Docker file is a file that you create, which in turn produces a Docker image. As you can see in this image, so you can see Docker file is a set of instructions that is used to run a image. So if you want to create an image, a Docker image, basically you need to perform two actions. So the first action will be is to create a Docker file, and the second is to run the same file using some type of build command or something that uses that Docker file. So this is a small example of a Docker file, and we have created a first Docker file in my part 1. So you can check out that. So Docker file, basically, if you will build a Docker file, it will result into an image. So image is nothing but image is somewhat like a file-like thing that since it get built, so a Docker file contains a bunch of instructions which informs the Docker that how the Docker image should be built. Now, moving on to a Docker container. So what is a Docker container? A Docker container is a running instance of a Docker image. So if when your image is running, it results into the Docker container. So in last part, we also saw how to run a container and how to make it lasted long, but I will be showing it again. So what I'm doing is currently I will show you one thing over here in Katagoda. So containers are nothing but there are Linux processors. So in order to show that thing, I will be sharing my screen of Katagoda. So I will increase the font little. Okay, so what we are going to do is now I will run a container in the Katagoda and will show you container is nothing but a process running on the VM. So for that, what we are going to do is I will be running a Ubuntu container in a detached mode, and I will be explaining it later on what is detached, attached, and so you can also go ahead and try it with me. You can also run a Ubuntu container and make it sleep for some time. So basically this command will run in background. So now if so our container is running, if you want to check it. So we have our Ubuntu container now. So what I will be doing is clearing my screen, and we will be checking all the Linux processes running on the server. So now you can see this is our container running over here, and this is the process ID. So in order to show you guys that this container is nothing but a process, what I'm going to do is I will be killing this process, that is 3619, and then you can notice that container is no more. So I'm killing it. Let's go ahead and check out whether it is still running or not. No, it's not there. Let's clear out the screen and go again here and check whether our container is there or not. So it's not there. So this is how I wanted to show you that container is nothing but just a Linux process. So let's move ahead with our PPT, and I hope now by now you have understood what is Docker image, what is Docker file, and what are containers, and what is the difference between VM and Docker. If you have any questions, containers, if you have any questions, you can go ahead and put in on the chat. So let me go back to my PPT. So next, what we will be learning is the container life cycle. So what I am going to show is when we run a container, so it keeps on running. It is in running state till it has something to do, like it has some set of instructions to perform. Once the set of instructions are over, the commands which it need to perform are over, it turns out into the stop status. And if we need to start the stopped container back, we can do so. So this is the container life cycle. So containers are ephemeral in nature and they just do their task, and after that it exit. So I will be going back to the Katagoda and showing you the life cycle of the container. So you can always perform these steps along with me. If you have any doubts, Sangam and Sayam are there to help you out. You can post your questions in YouTube. If you're facing some issue in the output as well, you can do that also. So back to clearing the screen. And now what I am going to do is I will run again I will run a Ubuntu container, this time 16.04. So Ubuntu. So you can always provide the version which you want over here. Latest one, 16.04, anyone if you want. So now it is pulling. So in my last part one, I have explained the concept of layering as well, like why full for pull complete over here it is written. So before showing you container life cycle, I would like to show you one fun fact over here. So I'm opening a new terminal from here. And as we have run Ubuntu 16.04, what I'm doing is we'll be checking once. So what we are noticing over here, and you might be thinking as well from where these names are coming from, like admiring underscore Ishizaka. How come, as we have not named our container, we have not given any name. So this name came from the Mobi project. So what I'm going to do is I will be giving you a sneak peek what is a Mobi project and from where does this name came from. So you can always go to Google and type Mobi project GitHub and come on to this link. So I will be sharing this Mobi project. So this is the Mobi project which I'm talking about. So Mobi is an open source project created by Docker to enable and accelerate the software containerization. So it is also open source and it helps to accelerate the software containerization. It is an open project guided by strong principles aiming to be modular, flexible, and without too strong an opinion on user experience. It is open to the community to help and set. So I would really want you all to go through this Mobi project, what it does. But for now, what I'm going to do is I will show you from where this name is coming from. So let's go to PKG. Let's go to names generator. So here names generator is there. Now let's move on to names-generator.go. So these are the names defined over here: Albati, Ellen, Almeida. So these are very famous people in the community. So you can read out the descriptions as well if you want. So Agnesi is Italian mathematician, philosopher, theologian, and like that. So from here in, we are getting those names if you're not giving name to your container. So this was a little fun fact. Now moving back to our container life cycle. Okay, I will share my Katagoda screen again. So this is what I wanted to show you from here. So now what happened is we are inside our container, and what I am going to do is I will exit from this. So now we are not inside the container. Back to this terminal, and here we go. So now the container is not there. As soon as I exited from the container, it went into a exited state. So if you want to see, you can always type -a and see over here. So now our container is in exited state. So as I explained earlier, containers are ephemeral in nature. They just do their task, and then after completing their task, they exit. So this is the thing over here. Now what I'm going to do is I will, if I want to uh, do something again into this container, we can start this container again using docker start command. So docker container start. So I can do docker container start and the name. So we can go on to the second terminal and just copy paste the container name and do so. Okay, so now let's check it out whether our container is running back. So I need to perform this repetitive task in order to show you the container life cycle. So yes, it is running now. So what we have started it, we have started a container. Now what I'm going to do is we will attach this container. So how to attach the container? Docker attach. No need to give this full name. You can just write this much. So this is the way we can do it. So and now moving back to my PPT, first I would like to explain you what is attach, detach. So I hope now you are clear about the container lifecycle, how it is working, how it has done the things. Okay, now coming to attached and detached. So if I will run Alpine image or something, so it runs the commands in the foreground. And if I am giving this docker run -d anything Ubuntu sleep or so this command will run in the background. This docker container will run in the background. And if I am giving the docker attach, so what it will do is it will run the command, the entry level command of the container. So in order to show and make you clear, I will go back to Katagoda and show you. I have one more example to show you how this Docker container, how this attach command works. So what I'm going to do is I will run a container again. So Docker run in detached mode. I'm running one container and this time I'm keeping name. So you can always name your container using hyphen name, top demo. You can always go to docs.docker.com for clearing your doubts and you can go ahead and read it out from there. So I have taken that command from there so that it is clear to you. So this is the command. So we have ran it successfully. Now what I'm doing is now we will attach this top demo. Let's see what happens. Okay, so as I explained, it has given us the entry level output of this container. So this is top command and it has given the total usage and CPU utilizations. And this is how the attach command works here. So let's come out of this container and let us go back and see how many containers we are having. Let's clear out the screen. And what is the command to do so? Docker container ls-a. So we have these many containers now running. And now we will check how many images we have with us now. Okay, these are the images we are having right now with us. So what I'm going to do is now we will be going to a path cd var lib docker. So as you can see, it have few folders in here, that is containers, images, overlays, so network. So whatsoever images or containers you will spin up, you will use it. It will be stored in here. So let's go and explore this more. So let's go to ImageDB to check out what and all images are available with us now. Okay, so these are the images that are available with us right now. So in order to show you, I will use this terminal and show you if these are same. So let's check out for this image if these image are there or not. Let's go to terminal and you can see this B7B are there is there, and let's check out for this 355. Yeah, it's there. So this is how you can always verify what are all images are there. So let's clear out the screen and I will give you this path. So this is the part to check the image. For now, we have checked the image. Let's go back and check out for the containers. How to check the containers. Let's go in here. You can ask your questions in the YouTube chat. Sayam and Sangam is there to help you out. If you're facing any issues in running container or anything. So these are the containers available with us. I can switch back to the terminal one and so we can check out for these containers over here 8485E. So 8485E. So this is the path where you can check and cross check your things. So now what we are going to do is we will try to remove our images and containers. So I will show you the command to do so. So let's go ahead and remove some one container, and let's clear both screens. And in one screen, let me check out for the container. So let's try to remove this container. So let's try doing so. Let's see what happens. So what is the command to remove or to stop a container is? Okay, it is showing no such container here. Why it is happening so? As you can see in here, it isn't stopped status exited. So what we are going to do is we will try to remove some images. Let's see what happens. So these are the image. Let's try to remove this alpine image. So the command to remove the images docker rmi and then id. So it has successfully deleted your alpine image, latest alpine image from here. So this was the thing. You can always try it out and play around using Katagoda. You can try removing and creating, pulling. So now what we are going to do next is we will be pushing a image into the Docker Hub. So part, I have showed how to create a repository and account in Docker Hub. So I have my own account, Saloni1814. So you can go ahead and do so right away. If you have any issues, you can just type in the chat. So what now we have removed. Now what we are going to do is we will log in our Docker Hub. So this is how we can log in. So I need to provide my username over here. You need to provide yours. And let's go inside our Docker Hub. So login has succeeded. Now I am inside it. So if we need to push or pull images from Docker Hub, we have to log in. If we need to push. So let's clear the screen. Now let's go ahead and check for the images again. Okay, now what we are going to do is we will be tagging this Ubuntu image. So how to do that? Let's go to the other terminal. And how to tag your Docker image. So you need to type Docker tag, and then you need to give this image ID. Let's go ahead and paste it here. And now I will be tagging it as you can provide your name in here. So I have already created one repository in there in Docker Hub. You can also go ahead and create it. So as you can see, I have this already available. So I will be using this one for this demo. And I will be tagging this image with V1. So in order to do so, what we need to do is, so let's see. Yes, now our image has been tagged. Let's go back in here and see now what all images are available in here. So you can see this the image which we have tagged with V1. It is available in here. So now as we have tagged in our image, now what we are going to do is we will be pushing this image to my Docker Hub. So in order to push this image, nothing, just simple, you need to write Docker push and this image. So let's type in here Saloni1814 Docker quick. Let's see. So it is preparing and it will push it to this repository. And after that, once it is completed, which we can see it's done, we will be going to our Docker Hub and refreshing it. So when we'll refresh it, we can see one V1 has been pushed it here a few seconds ago. So this is how you can push your Docker images to the Docker Hub. Okay, now suppose if we want to pull this image, if you want to pull your image from Docker Hub, what we are going to do is normal simple command we need to give Docker pull, and I have created with Docker quick. So image is up to date because we already have. So it tried pulling it from Docker quick, and it's in there. This is the name. So So we have this image now with v1 tag. You can tag it with v2, whatever you want, whatever is your wish to do so. So now I hope you are clear with this concept of Docker file, Docker image, and Docker container. And as I have mentioned earlier, this is a Docker file. You can go to my part 1 and do so. And this is container lifecycle. Now what we have just done today is we have started a container and typed in exit to come out of the container. It went into the stop status. And then when it is stopped, we tried to start it again, and it again came to the running status if you want to change. And this is the attach and detach mode, which I have explained it today. So if you give -d or detach anything, so Docker container will run in the background. And attach mode is always used to use the existing container to perform some actions on the existing containers. So this was all for today, guys. If you have any doubts, you can reach out to me on my Twitter handler, that is I__Saloni92. Now over to you, Sayam.